Right, good morning, everyone. So thank you very much for the opportunity to come and present here at Biomedical Science. I have to say this is my first rodeo with this community. I've been very interested to see what you guys are doing. Following that, I should probably give a small disclaimer. I'm giving this presentation on behalf of my colleagues. So I'm relatively new to the cloud computing business, and I'm an oceanographer by training, so I'm way out of my depth here. But be that as may, so I'd like to talk to you today about our cloud container compute service that we have at EGI. And to give you a bit of an outline of what I'll be talking about is I'll talk about EGI and the Federation, just to give you some flavor about what we do. Then give you a sort of high-level overview of some of the services, and then dive into the sort of Egi Federated Cloud and the cloud computing and cloud container computing services that we offer there. And then provide you with some examples of the communities that have been using our service. So to dive right into EGI, our mission is to create and deliver open solutions for science and research infrastructures. And we do that by federating digital capabilities, resources and expertise between communities and across boundaries. And we want to do this in order to enable researchers from all disciplines to have easy and integrated open access to advanced scientific computing capabilities. The Egi Federation is effectively a group of resource providers, computing and data centers that are federated and provide their resource offerings through the Egi Federation. We offer a fairly wide range of services. In terms of some of our offerings, in terms of computing and resources, is a high throughput data analysis service, the Federated Cloud, which allows you easy access to the European infrastructure as a service and platform as a service, which also supports the Docker and Kubernetes service that I'll be talking about a little bit later. There's open data processing, federated operations, and we assist communities and co-create solutions and support researchers in their applications. And then we also have a policy team that provides advice on research and policies. So our external service portfolio looks a little bit like this. We have some broad categories under compute, storage and data, training, some applications on demand and notebooks, as well as security. And these services are effectively provided through our well, actually, mind you, I'm just going to talk about those two later, but that was the point of that. But the thing I wanted to note here is that we have an internal service portfolio as well, and this is effectively the services that allow us to federate the many computing centers that are part of our federation. So these services are internal and enable us to basically collaborate with the many computing centers that we work with. And then finally, we are certified. Basically, we have a commitment to excellence, and we go through audits to ensure that we maintain a quality system and that we have improvement services. So we are ISO 20K and ISO 9K certified in that sense. In terms of delivering services to SMEs and industries, we essentially allow people access or we enable access to resources so people can test their workflows, pilot their applications, and develop their services. Our mantra is to focus on reusability, so you can capitalize on open research data, tools, softwares, and applications. And you can team up with our experts to deploy your applications in the infrastructure and then co-develop applications. And then our communications team facilitates visibility and networking opportunities through through events, publications, and our network. Now, next I'd like to talk to you about the Federated Cloud and the Cloud Compute and Cloud Container Compute service. Effectively, the EGI Federated Cloud is a multi-cloud infrastructure as a service with a single sign-on via our check-in service. Effectively, what this enables you is to run virtual machines on demand, similarly to what AWS and Google Cloud Compute are doing. The technology is agnostic, and it's based on OpenStack and OpenNebula and Cinefo. And we have some additional features, such as the single sign-on, an applications library, resource discoveries, single GUI dashboard, and computation near data. Now, the federated cloud is essentially enabled through 21 cloud providers, mostly academic, private, and virtualized resources across Europe. And the point is that we have a diverse group of providers, but we have a common sort of solutions that allow us to work across the different resource centers. Here's kind of an overview of the architecture that we have across the infrastructures. And this is just to point out that effectively the federated cloud is not just an applications database, but rather we have providers have their APIs that can be used with the EGI check-in accounts, which then opens the door for automation of cloud-native applications. And the infrastructure as a service federated access tools layer helps users of the cloud to deal with the heterogeneity of the different IaaS APIs and the EGI Federation services. And then the EGI Federated Cloud no longer mandates a single API for every provider, although this is a typo, I think Oki is still widely used, widely supported, but sites are moving to native APIs, mainly based on OpenStack. So the applications database, or the VM Ops, is where you can manage your virtual machines. We have a wizard-like creation of virtual machines which is completely integrated with check-in, and you have a single dashboard of all of the providers with the virtual machines that are run there. We group topologies are essentially a related set of virtual machines depending on your application. You can manage them globally, or you can manage them individually, and it's integrated with GGAS as our help service, help desk. The access to the resources is kind of managed through virtual organizations, or VOs, where we have community-specific VOs such as Chipster or ASCAT, that basically, if you're a community of, for example, Comp Biomed, you would fall into one VO and you would access the resources through that. We also have a training VO, as well as a generic VO for people to test applications, which is kind of like you can log onto it for a limited time. For about 6 months, you can test and pilot your applications before we put you onto a community VO, for example. If you're interested, you can browse the various VOs that are available at this link here. And Christian gave a very nice overview of VMs versus containers, I think, but I just wanted to, this is mostly for myself, to remind ourselves what the difference is between VMs and containers. Essentially, it's virtualizing hardware to run multiple OS instances, or versus containers that virtualize OSs to run multiple workloads. I'm not going to spend too much time on Docker. The EGI Cloud Container Compute service is based on Docker, and we use Kubernetes as the container orchestration instance. But I'm not going to spend too much time on this unless you want me to. I think you're all familiar with this. Right. So there's 2 options, or 3, to run containers on the EGI infrastructure. You can deploy a single node and start the EGI Docker VM and run containers directly, or with Docker Compose. Or you can use the EGI Cloud Container Service, where you start a cluster of virtual machines and then create a Kubernetes cluster to run your containers. Or you can run, the third option is to run uDocker on containers as jobs in the EGI high throughput service. The service architecture and interface looks something like this, where you have the EGI Cloud Compute Service, including the cloud management framework and the federated access tools. These then provision the cluster virtual machines, and then on those you deploy the Kubernetes cluster, and then you can use the native Kubernetes tooling together with our check-in service to manage your application. So to compare the various cloud compute, cloud container compute, and HTC, basically there's, in the first row you see what it is. Basically, the cloud compute is a multi-cloud infrastructure as a service, whereas the next one is the cloud container compute is Kubernetes on top of the cloud compute. and then the grid is just there for comparison. But effectively, what you run here is VMs, here you run containers. This is the typical workloads that you have, and here are some pros and cons for the different services. So I wanted to move on to some of the examples of community use cases that we have. I'm going to briefly talk about three. The first one is the EGI Notebook service, which is essentially a Jupyter Notebook as a service where it's a one-click solution. You just log on and start using the Jupyter Notebooks. And this is the architecture where you see the communities managing the various containers. Then the next use case I have for you is this Global Earth Observation System of systems, which is a satellite remote sensing application. The problem is that the Earth observations are usually underexploited, and there's this whole spiel about the UN Sustainable Development Goals and that we need to make better use of Earth observations in order to support those actions. Through the EOSC, the European Open Science Cloud portal, we are making the services discoverable, allowing users to identify related workflows, explore the available data, and then execute the workflows using the European Open Science Cloud infrastructure. The architecture looks something like this. We have a variety of applications and systems that need to talk to each other, and the remote processing services, as well as the VLab portal and apps, are run using Kubernetes and Docker containers. The next use case is Elixir's Global Alliance for Genomics and Health, which is an international consortium of academic and industry partners that try to establish standards to promote and facilitate collaboration and data exchange in life sciences. The TESC is an implementation of the Task Execution Service standard, which is using Kubernetes container orchestration to basically stage in and out data and execution tasks. The architecture for TESC looks something like this, which is then managed largely through the Kubernetes thingy. Now, if you're interested in getting started on our service, you can request access to the EGI resources through our marketplace. And specifically, if you're interested in the container compute service, there's the link for that there. And our documentation on how to deploy Docker and Kubernetes in the EGI Fed Cloud is given by that wiki there. Lastly, I would like to take this opportunity to just promote an upcoming event. We have our annual EGI Conference here in Amsterdam from the 6th to the 8th of May. And this is an opportunity for research communities, the IT service providers, the technology providers, to come together and present and co-design service for advanced computing in Europe. In addition to the main event, there are two co-located events on the day after the main meeting. The one is a Design Your E-Infrastructure workshop, and there's a FitSM, which is IT service management training, a lightweight version of it, on the 9th of May. And you can find more information here. And that's me for today. Thank you. Short and sweet.